Okay, continuing our NumPy tutorial. In MATLAB, you can do things like this where you can call the first row and all the columns, like so, or first row and just columns 2 and 3, like so, or etc. Right? So you can also have something like this where you can specify whatever rows here. If you have, if you want, if B were a 3 by 3 matrix, let's say, if you just wanted rows 1 and 3, you can do that, etc. Okay. How about in Python? How does one do that in Python? Before we talk about that, I want to re-emphasize in Python, there's this concept of range. Range. If you say range 4, if you recall, print e, it does 0 to 4. What that means is actually 0, 1, 2, 3. Okay. So that's important to remember that in Python, the range command, which is related to doing something like this, actually is what's called not inclusive of the last element, I guess. So range 0, comma 4 actually means 0, 1, 2, 3. So remember that, and then we will see, we'll do this kind of thing, but with in Python. Okay. So let me just print B again, just so that we have it in front of us. Okay. And let's say we want to get the first row, which is actually the 0th row in Python, and all the columns. Okay, let's try that. So B 0, then we can say print of that B 0, comma everything. Let's try that. Okay, 0, comma everything gives us all the elements there. But let's say we just want these two columns. Print B, because I'm more familiar with MATLAB, or vastly more familiar with MATLAB, I always make these MATLAB-y mistakes, but that's okay. We can always catch ourselves. So we can say 0 to, we can say 0 to 1. Let's see what 0 to 1 means. Then let's say run. It just gives us, rather than give us column 0 and column 1, it just gives us column 0. Okay, it just gives this thing 3. So if you really want columns 0 and 1 and row 0, we really need to do, it looks like, how do I, okay, there you go. We really need to do print B 0, comma, and then instead of saying 0 to 1, we go 0 to 2, and then we actually get column 0 and 1, because in Python, 2 is dropped. When you say 0 to 2, it's actually 0 to 1. The end is actually 1. So, and the sort of the rationale is when you say range 0, comma 3, it's actually start and stop. So it goes 0, 0 is the start, 3 is stop. 3 is not the end, it's actually stop. It's slight subtlety of wording. When it goes 0, 1, 2, and then when it comes to 3, it stops. It doesn't include the 3. When it stops, it just stops when you get to 3. Okay, so It's 0 to wherever you stop. Okay. So that's how you do that. If you want all the rows, you just go B. And if you just want the first two columns, you go 0 to 2. Oops, I used parentheses there. Okay, hopefully we got that right. All the rows and then the first two columns. Let's try that. Okay, and we got that. Okay, so that's how we call it. And this, if you're new to Python, will take some getting used to. I'm certainly much more of a MATLAB person, so I'm not super used to this, but you'll get used to this if you code in Python a lot. Okay. Okay, so that's how you call various things, specific rows and columns. Okay, so we've gotten until somewhere out here. Let's do a couple of more things. In MATLAB, when we have, let's say, b like that, we can define some new function d by stacking b's. So this would be like vertical stacking, or we can do horizontal stacking, like so. So put b right next to each other. In Python, you can do that as well. It's called vertical stacking and horizontal stacking, like so. Let's try that. Of course, to be able to do this, you will need to have matrices that have the same size or whatever appropriate sizes. If you're doing vertical stacking, it needs to have the same number of columns. If you're doing horizontal stacking, it needs to have the same number of rows. So let's do vertical stacking of B with itself. Doesn't work. Why is that? Because this is the syntax, okay? Let's do it like that. Okay. Print E. Okay, so we vertically stacked it, and then we can do horizontal stacking if we want. Yeah, of course you can have like different matrices here. I'm just doing this because I don't want to define another matrix, but hey, that's okay. Okay, so I'm just stack that like that. How about we do this? We can do 2 times. So we have stacked B and 2 times B right there. Okay, so that actually leads us very naturally to element-wise operations. I just displayed something, and element-wise operations in MATLAB is very easy. You just do, if you want to multiply a scalar with a matrix, you just go whatever, scalar times matrix. And in Numpy, it's exactly the same. You just go scalar times matrix. So you can go print. If you want to do 2 times B, you can do that. Or if you want to do print 2 plus B, that works too. It will add the number 2 to every element of B. Same for subtraction, same for division. What else? You can do sine, cosine, and so on. So you can go print sine, but you have to go np.sine because it's a numpy function of B. And then it does element-wise sine, so it takes the sine of every element, cosine, tan, log, everything, exactly the same, np dot, right? This we saw last time. If you want the number pi, you have to go np.pi. That's how you get pi. In MATLAB, of course, you just go pi, format long, get that. So in Python, you just need to remember to use the appropriate library that you've imported to call the various functions in that library. Okay. Um, okay. So um, if you want to do so, this is let me show another element-wise operation. Again, we have print b. Just to recall what b is. We can do let's say, I don't know. We've already said e of g equals 3 times b, let's say. Okay. Print g, some matrix g. And then we can do h equals b times g and print h. This actually does element-wise multiplication in Python. So b times g, b is a 2 by 3 matrix, g is a 2 by 2 matrix, and when you go b times g, it actually multiplies the corresponding elements of the matrices b and g. If you want to implement that in MATLAB, oops, g is b 2 times b. If you want to implement that in MATLAB, you have to go b dot multiply g. Okay, that actually does element-wise multiplication in MATLAB. In MATLAB, if you did b times g, it'll say error, because in MATLAB, by default, this multiplication sign actually corresponds to matrix multiplication. Okay. And if you have matrices of the same size and if they're not square, of course, you cannot multiply the two matrices. For this, you can, if you want to do matrix multiplication, this will work. This is the matrix multiplication of B and G transpose, and now they have consistent sizes, namely the number of columns of B have the same number as the number of rows of G, or the second matrix, G transpose, I suppose. Okay, so that works. Now, how do you do matrix multiplication in Python? So let's try that. Before that, let me just show print all the stuff be divided by G. Again, this is like matrix element-wise division, not inverse or anything like that. Okay, very important. Matrix multiplication, this is how you do it in Python. If you want to go to the cheat sheet maybe it has it, maybe it doesn't. Maybe it doesn't, I don't know. You can look it up slowly, but you would just Google matrix multiplication in Numpy, and you would go to the correct command. So if you want to do matrix multiplication, let me just define some matrices here. So again, we have print b, and then let me define another matrix with 3 rows and maybe 1 column or something. G, H, I, J, K, P, let's say P. So this is how okay, so let's see if we can multiply B and P. So you go np dot matmul B comma P. Let's try that, and it's happy. You take a 2,3 matrix and 3,1 matrix, and you get 2,1 matrix. Okay, 2,3 times 3,1 gives 2,1. Okay, so that's how matrix multiplication works. Okay, so that's how you do matrix multiplication. We can say, instead of saying this, we can say print of that. We'll show it to you like that. Anyway, you can verify that that's the matrix multiplication of that. So I think this is the same B that we've had before, and P in this in Python we just defined as basically 3 to 7, and what we did was B times P. That's this matrix multiplication. Okay, same answer. Okay, if you're making some progress here, making a correspondence between MATLAB and Python, specifically Numpy, we can do determinant, eigenvalues, inverse. If you have square matrices, you can do determinant and inverses and eigenvalues. So let's do in MATLAB, of course. Let me just do I don't know, some random square matrix. P equals 2, 3, or not 2, 3, something like that, and then we can go I of P, inverse of P, determinant of P, all these things. In Python, you can do something similar. Let me just define some array, np dot array, and then let me define this exact matrix here. Okay, same matrix, 3, 4, 2, 3, and then we can say let's just try it out. We can say np dot eig. So when I say np.ei, it doesn't quite tell me what if there's a function of that kind. So let's try p.eig. Doesn't seem to be there. So let's actually look through here. Matrix eigenvalues. We have to go linalg.eig of A. Okay, so linear algebra.eig of A. Let's try that. Let's try it both ways. Doesn't work. I'm just trying to see if there is any tab complete. So we can go np.linalg. Now that works. Of eig of P. Okay, so that works. Print. So you want to try things like this. Okay, so apparently that doesn't quite work. Why is that? Computes the right eigenvalues and right eigenvectors of the array. So let's actually see what those things are. So eig gave us these two numbers. These are the eigenvalues. And if you look at this closely, it actually agrees with these things. So the first array that it returns is actually the eigenvalues. And the second array it actually returns is actually the eigenvectors, which you can do in MATLAB as well. So in MATLAB, we can go d comma v. I guess v comma d in MATLAB. The eigenvectors and then the eigenvalues. So these are the eigenvectors. The columns are the eigenvectors, and then the diagonal of this matrix are the eigenvalues. Here again, the second array, the columns 0.8 and 0.577 are the eigenvectors, and then these are the eigenvalues. Okay, so that we've now made a correspondence between the I function in MATLAB and this function in Python, or specifically Numpy. Okay, so I kind of intentionally didn't look up how eig is done, so that I wanted to show you how you would quickly look up how to do this in Python. And then if you just want to do a check of your understanding, and if you're familiar with MATLAB, you can do a check quickly of the corresponding function in MATLAB. Okay, just make sure that things work out. You can do the same for inverse. Let's try inverse here. Let's try np.alg.inv. There's a completion there. That apparently is the inverse. If I go in inv of p, 2 minus 4, 3 minus 4, minus 2, and 3. Here's just showing the closest integer, I guess. There are small differences. I don't know if we can do format long here as well. Let's ignore that aspect. If I go format short here, MATLAB will also show this. Okay. Okay. Making progress. Here's a funny, weird thing. If I wanted to take one matrix and then define another matrix equal to that, so let's see. If I go Q equals P, let me print P again, print P, and then Q equals P, and then print Q, okay? So P is this, Q is this, that's all fine. And then let me go Q 1, 1 equals 100, and then go print Q. Okay, so I've just set this element to 100. Let's try something here. Let's say print P. Okay, this is really weird. You have to be super careful here. It's a weird aspect of Python, which has to do with, it's kind of related to pointers in C, I suppose. So we defined Q equals P, and Q was equal to P. And then we changed Q, an element of Q, and then we printed P, and sort of surprisingly or weirdly, the corresponding value of P has also changed. And that's because I think there's sort of this one-to-one mapping between Q and P. So whatever changes to Q happens to P as well, because we've set them equal to each other. They're sort of stored in the same memory location, I think. So if you actually want to say Q equals P as in MATLAB and not have P change when you change Q, then you have to actually copy the values of P into a new variable called Q. So what we really need to do is do something like this. So we can say Q equals np dot copy P. Okay. So then we can go print P. We've already changed P now, so it's going to be this. But now we can change Q. Q 1, 1, let's say it's 200. We can print Q, and then we print P as well. And now notice that Q has changed, but P has not changed. And that's because Q is now initially a copy of P, and then now when we change Q, P does not change anymore because we've sort of created this new variable. Okay. So that's something to be super careful about. Let's see if this happens if we actually do something like this. Q is 2 times P, and we can go print Q. Um, Now, here, I think it's immediately created a copy so that if you change Q, nothing happens. And then we can say print Q. And then we can go, I don't know, Q of 1 comma 1 is 400 or something. And we can say print Q, print P. So when you do this, P doesn't change, P remains the same, but Q does change, okay? So this quirk is primarily when you say Q equals P, then it sort of behaves in this weird way. But if you obtain Q by some mathematical operation on P, then it doesn't any longer have this weirdness where when you change Q, it changes also changes P, okay? So that's something to remember, weird source of bugs potentially, okay? Okay, let me end that video there, and then we will do other things in the next video.